Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this video, I would like to show you how I will do assembly drawing from this full assembly of my mini blender. As you can see, I already completed the full assembly of my mini blender in the previous video. So in this video, I want to show you how I will create the assembly drawing from this full assembly. But the first thing I need to check, in order for us to do full assembly, the one thing is to make sure that all your parts in a correct position. So you mean in position is right. So one thing that I noticed that if I go for the top view, it's kind of like the direction of my lid and also the handle is kind of like slanting to certain angle. So let me go back to isometric modes. I need to make that this lid and also the handle, since the handle will follow the lid because I have already set the made setting. The only thing that I need to change is the lid itself must be perfectly horizontal. So it means that if I go to top view again, if you look here, the orientation that the lid is kind of like not in horizontal orientation. So in order to do that, I need to add another made setting for the lid. So if I click in here under assembly, we have made. I must make sure that in here for the made setting, I will select the lid front plane will mesh with the, if I off here the list, with the main front plane of this assembly file. So then if you look here, our lid and also the handle will follow if I go for top view, and it is perfectly horizontal. Okay, now I save my assembly file. Okay, another thing to do in assembly, before you do we create assembly drawing, we must make sure the order of our assembly. If you look here, I already done the assembly. If you look, the order of my component is not in proper order. So because before we do assembly drawing, so we must make sure that all the component here, the part that involved in this mini blender are in order. What I mean, let's say when you dismantle this mini blender, you disassemble it and you want to assemble it again. So the order of your parts must based on the proper order. So it means that what will be our base. For example, if you want to assemble back, this mini blender, our main component or our base component should be the lid. So my mistake. Our main component will be the container. So the container will be our base of this full assemble. So it means that this container, if I look on this container, where is my container? Container is here. I can drag this container, drag it up until it will become the first in my list. Okay, let's go back. Sometimes you cannot drag to the top like this. The lid here, I make it lower. So container will be number one. So container will be the base component. When we want to assemble back this mini blender, after we have container will be the base, what next will be? Okay, let me go for section this front view to better explain to you about the orientation of this assemble. When we want to assemble this mini blender, the first thing will be the base. So the second component will be the shaft. Then we will mount the shaft. Then the second component will be the shaft. Then we will mount the blades and the screw to the shaft. So the vertical shaft, we should drag it. It become the second component right after the container. Then after the shaft, we will mount the blades and the screw to the shaft. So the third component will be the blade. So I select the blade, I drag it up until it becomes the third component. And then we have the screw. We have small screw here, and the screw M1.5 here will be number 4 right after the blades. Okay, then this shaft will be mounted on this main component, the container. Then we will mount the rubber ring. So the rubber ring should be right after the screw. Okay, if you look here, the order is proper. First is the container is our base, then we go for vertical shaft, the blades, the screw, and the rubber ring at the bottom. So this will be sub-assembly of our bottom components. Okay, then we go the sub-assembly of the top component. After we have assembled the bottom parts, then we will assemble the top parts, the sub-assembly of the top parts. So the sub-assembly of the top part, the base will be the lid. So the lid here should be, I drag it right to the bottom of rubber ring. As if you remember my previous video where I do the assemble of this component, after the lid, then I will mount the base plate. So the base plate will be, okay, the base plate now is right after the lid. Then after the base plate, then we have coil spring. So the coil spring, if you look here, is in order right after the base plate. Then after the coil spring, we have the pulley. Now we have the pulley. Then after the pulley, we have the screw. Now I have the screw, so it means it's order. Then I have gear lash. Then I mount the gear lash. Then I mount the gear lash because we have 2 of them, gear lash 3 and 4. And then I will mount the internal gear. So it is in order. Then after the internal gear, then we have the handle. So the handle, we assemble the handle, and then we have the middle plate is the last of our sub-assembly of our top parts. And then we will mount all this assembly on the top parts to this sub-assembly of the bottom part. So it means now my components are in order. So better to do it like this. So make sure that the order of your component must be ordered. So that's why when you do assembly drawing, okay, let me save off, maybe off this thing. I save again. So now I save it, and now what I will do assembly drawing. So to create assembly drawing, I will click at the new document here. We have arrow here, so I will go for make drawing from part assembly. Okay, Solidworks, it will ask for the standard sheet size. What is our size of our drawing? A1, A2, they have all the here in the library. But in this case, I already done my template for the drawing sheets. We're in A3 size. I will browse my template that I've done. Hold on. So this is my template. I click OK. This drawing sheets is in A3 size. They are already done. Okay, how to create this title block? This template, I already put the link under the description of this video. I already have done the video how I create this title block. You can look at the link under the description of this video. Okay, if you look at this interface, okay, this is now we create engineering drawing, we create assembly drawing for this full assemble of this My Mini Blender. If you look the palette on the right, if I click somewhere here, the palette disappears, so you can make it appear again. If you look on the menu, we have here view palette. So okay, if you look at the top, so this is a file where that link to my assembly, which is my full assembly file. Okay, if you look on the menu here, we have all the view that we can drag into this assembly drawing. Okay, before you drag the view, so you must think first for this kind of your product. My product is a mini blender, so you not simply just drag all the views. Not necessarily all the product you must drag top, front, and side view, because this kind like product like mini blender, the best view that we should drag is top view, front view, and also automatically if you look, Solidworks will detect for the top view. And if I bring it to the corner and we go for isometric view, okay, let me to cancel it, just press escape and we cancel it. Okay, this isometric view I can drag it somewhere at the corner here. Okay, one thing to do here, if you look all this view of our drawing, they have a sketch here, it show, so we can go under view, under height show, I off the sketch, so we have a clean view. All right, another thing to do, if you look, this is a top view, this is a front view. If you look at this front view, I click at the viewports. If you look the menu setting on the left here, if you look under the scale here, if I go for custom scale, the by default is 1:2. Under the custom scale, let's go, I want to go for full scale 1:1. But if I click at 1:1, if you look on the screen, it's kind of like too big. So I think it will not fit into this A3 size paper. So I will go back to 1:2. So I will go back to 1:2. So it is reduced. Okay, I think 1:2 is good enough to be fit into this A3 paper size. Okay, another thing to check, if you look, if I zoom in on the top view, the view show all the edges. So for proper engine drawing, these edges should not be shown. These all kind like tangential edge. So to remove that, I can go to this viewport, I click at it and I right click at it. I will go to under tangent edge. By default is tangent edge visible, so I made tangent edge remove, so we have a nice proper outline of the object line of our top view. Alright, okay, if you see again in this top view, we have a full circle, of our product. So better we click, let me click OK first. We create a center line. In center line in Solidworks, if you look under annotation tab here, we have a center mark. I create a center mark, I simply touch the circle line, automatically the Solidworks will make a center line. Alright. Okay, another thing about this product, this is a mini blender. So most of our component like the shaft, the blade screw, the internal gear pulley, blade plate and so on is inside the component. So it's not showing in this front view. So for this case, an assembly, for this assembly drawing, we should do a section. Normally in assembly drawing, we have a full section. So what I will do, I will replace this front view by a section view. So I select at this front view and I delete it. I click yes. So what I will do, this top view will be my cutting plane and I will do a full section, and at the bottom here will be our section view from this cutting plane at the top view. So what I will do in Solidworks, if you look in Solidworks, under the drawing here, under drawing tab here, we have section view. We have section view, I click at section view. If you look the menu on the left, we have vertical, we have horizontal, we have angular and also align. So in my case, I will do the horizontal, I click the second one, then I will bring it to the center of this and I click OK. Then okay, there this will appear, this menu will appear. We can select any component that involved with our cutting line. For example, like standard component like screw, like spring, if we have ball bearings or maybe a plain shaft, this component need not to be hashed when we do section. So I can select certain component which not to be included in section line. So in this case, I simply click OK because I will do that later. I show you. Okay, now we have a section view. I drag it to the front view. Alright, if you look here, this is our front view. And it also says section AA and our cutting plane here is AA. Okay, if I click OK. But if you look, this cutting plane is kind of like not the standard that we want, because since we use ISO, this is American standard. To change this cutting plane here, I can go under option here. Under option here, I can go, if you look under not system option, under tab document properties, I can go for views, and under section here, we look by default Solidworks use ANSI, American National Standard Institution. So for our course we will use ISO. So I will go for ISO, then I will use the first option. It means the standard with connector. So we have a center line and arrowhead. Then I click OK. If you look on the screen, it's changed into standard ISO for the cutting line of our section. Okay, another thing to check, if you look also here, the section line kind like too long. I can adjust the length if I click at it and I go for edit sketch, and I can select this thing and I can edit it, the line, I make it shorter, and also I select this line, I make it a little bit shorter. Then if I exit the sketch, and now my cutting line is shorter. Okay, the next thing to do, if we look here, the cutting line here, the labeling is AA. I can change this labeling to X. Make sure we use the capital letter, and now it changed to XX. And if you look, the labeling here, it is section XX. So let me drag this a little bit lower. Alright, the next thing is that if we look in the section view, okay, automatically Solidworks will do the hatching for all the components, including the standard component like screw. Okay, in standard engineering drawing, for assembly drawing, standard component fasteners like screw, even bearings, spring. If we have cutting plane that pass through this component, in the section view, this component should not be hatched. So in this case, I need to remove the screw by right click at it, under properties, then under section scope. Okay, this menu, in this list, we need to select the component we need to exclude from the hatch, from the section cut. Okay, then I select the screw, so the screw is listed here. So I need to check what is other standard component that really in section cut. So this shaft, actually for standard shaft engineering drawing also need not to be hashed, but for this case, this mini blender, this kind of shaft is not a standard shaft, it's kind of a custom made shaft, so I let it be hatched in the section view. So the only thing that I select is this screw. If I click OK, so now the screw will not be hatched. Alright, next thing is that if we look here, since Solidworks do automatically, it will hash all the other components. If you look, this is a section, this is a hatching line for the lead, and this is the hatching line for the handle and the pulley and the internal gear and so on. If you look, Solidworks didn't actually in standard engineering for different component, we need to put the hatching line at different angle. And then also, if we look, the distance between this hatching line is too far. So I need to reduce the scale of this hatching lines. So to do that, if I select this hatching line of this lead, if you look in this menu here, so basically Solidworks use material crosshatch. So I will uncheck the material crosshatch. So what I will do, I use the most basic pattern, which is parallel lines. I go for parallel lines, and if you look under the parallel lines here, we have the first one is about the distance of the hatching line. If I increase to 3 instead of 1, Solidworks will make the hatching lines narrower, so it become more dense. So I go for 3, but the angle I go for 45 degrees for this lead. Okay, then for the other component that next to this lead, for example, this is the base plate. I select the base plate. I'm also doing the same things. I uncheck the material crosshatch and I will use parallel lines. Then for this one, the scale is I put it 3. So 3 means it make more dense. Then I go for negative 45, because standard engineering drawing for component that next to each other, we need to different the angle of the hatching line. And for the pulley, so this is the base plate, this is the pulley. I select the pulley and use the same procedure, and I go for parallel lines. This I put 3 here, and this one I go for 45 then. So it means we need to make the angle different if the component is next to each other. So I will do the same procedure to all the other components. So I make a shortcut of this video, I pause it, and then I show you the end result. As you can see now, I already do all the changing for the section line. I already done for all the component. If you look the handle, this the direction of the hatching line for the handle is kind like in different angle, and also the internal gear and also the middle clip. So you must make sure that each component that beside each other must the flow of the hatching line will be at different angle, and also the shaft different angle. If you look, this is the rod of the internal gear, and the direction of hatching line of the shaft is in different direction. And also this the thickness of the lid also have hatching, and this is the rubber ring. Okay, I think I already done all the hatching. I already changed the setting of the hatching for all the component, and everything looks right. Let me save my file. Alright, okay, the next thing to do after I've done the hatching, the section view, the next thing to do is about the balloons and also the bill of material. Okay, in order to do that, I go for bill of material first. To do bill of material, BOM, so under the annotation here, sorry about that, not annotation, yes, under annotation, we have tables here. If I click at the arrow, we have bill of material. So bill of material, I need to select the view portion. So I will select this front view. So I will go for standard BOM standard. Then I will put this BOM at this corner. As you can see, automatically Solidworks will arrange the component from component number 1, item number 1 to item number 14. If you look the way the ordering of this part, the part of this mini blender, as you can see, the first is container, the base, then we have vertical shaft, blade, screw, rubber ring, lid, base plate, and so on. So the way Solidworks put into the list of this BOM is based on what I've explained earlier in this video about the order of we put into this list. So in this drawing, the list of this bill of material, the way the ordering of the list is right. So the only thing to do, since in this video I just show you the most basic way, actually there's a much better way to make to the title of this part number. So for this case, I just edit it. So instead of, because in bill of material we need to put it in proper name and also in capital letter. So I will double click edit. When I double click edit, it said do not click at break link. So I will say keep the link because this have kind like a link with the original part file of the container. So I will double click edit and I retype it and make sure that it is capital letter. So this will be the container. Then I will go for this one. Make sure to click at keep link, and this one I go for vertical shaft. I change it to proper name, also must be in capital letter. I click keep link and I name this blade. Okay, I will pause this video, so later I will show you the end result. Okay, this is the end result. I already renamed the all the component in proper name and everything is in capital letter. So the next thing, if you look in this BOM, the heading at this item number, I should name it as, I should rename it as number, and this part number I should rename it to name, and under the description here I put the change it to material and the quantity is 1. Alright, let me drag this BOM little bit here. Alright, this I select this column, then I will right click edit, I will insert column right. So I have column added here. So for this column, I will name the column drawing number. Okay, then let me drag a little bit like this. Make sure that it snaps to the border, and I can reduce this column. Okay, next I have the basic of this BOM. Alright, okay, the next thing under the material name here, actually to tell you, if we do more advanced way, actually the material will be automatically listed here by if we when we do the part modeling of each component here, actually we can put material of each component. But the purpose of this video, I just want to explain to you about how we create BOM in a basic way. So the material here later I will put it manually by adding text. Alright, one thing to mention is that also before I add the balloons, here if we look on the top view, we have the center marks. I need to add a center line here. So under annotation we have center line, so I just simply select these two lines of this shaft. So then Solidworks will put a center line there. Then I can adjust this center line. I will drag this thing, oops, not the view, hold on, and carefully select the line here. I make the line a little bit longer here, and also this line I drag it like this. So we have a center line for this front view. Alright, the next thing is that since this is assembly drawing, sometimes in assembly drawings, when we do assembly drawing, people also need to know what is the overall size of this mini blender. So I can do basic dimension, like for example I will give the radius here, so people will know what is the diameter of this mini blender, and also I will give dimension of the total height of this mini blender. Since in assembly drawing we will not put detailed dimensioning, we can put the overall size of our product, so it's okay to put like this diameter and the total height, so that people will know what is the overall size of this mini blender. Alright, let me save again my file, hold on. Okay, the next thing to do, I will add balloons. So if you look in this front view, since remember if I add balloon under annotation, if I click balloon, so I will show you how I add the balloons manually. So I will, the way, if you remember in the early of this video, I already shown you how, if you look, let me cancel the balloons again. If I show you the assembly of this mini blender, I already arrange the list of the component, the parts in order. The base will be the container and so on. So the automatically in the drawing of this mini blender, the assembly drawing, Solidworks will know the order, the numbering of the balloon will be based of the ordering here. It's based on the order that we already done in the assembly drawing. Okay, now I will do balloons, and I will add balloons. So I will point to the first one, should be the one, the container. So you go for one, and I will do after the container. If you look at the view, and here will be the vertical shaft, that I will point to the vertical shaft. If you look at when I do the balloons, so automatically when I bring it, they have a yellow line, so it means they maintain the line position of these balloons 1 and 2 in terms of neatness of the drawing. Then after the component 1, we have blade component number 3, so I will zoom into the blade. If I click like this will be the blade, and make sure that in line like this we have a yellow line there, so this will be the blade. Okay, in terms of neatness, I think I should, this pointer I should put it like this. Okay, this is 1. Then we have 3, the component number 4 should be the screw. I zoom in at the screw, I add the balloon, so pointing it to the screw. So this will be the screw. Number 4, number 5 will be the rubber ring. So zoom to the rubber ring, and I make it like this. So this will be the rubbering, number 5, and number 6 will be the sub-assembly of the upper parts. So number 6 will be the lid. So I will zoom at the lid. So I will put the lid here, 6. And after the lid, the ordering is, we have the base plate. The base plate should be number 7. I will put the number 7. If you look here, to maintain the inline, okay, you can see the yellow line here. So it will be 7. After that, we have a coil spring. Sometimes when you're pointing to your component, sometimes it have arrowhead instead of dot. Make sure you zoom in closer, and we have dot here. So this will be number 8. And number 9 should be is the pulley. So I zoom in at the pulley. I can go for here. I zoom at the pulley. So this will be the pulley. Make sure that in line at least. And number 10 will be the screw, and 3.5, or I zoom in at the screw. Make sure that I pointing to, make sure it's dot instead of arrowhead. So this will be the screw. So I put the here for the screw. Make sure that you have kind of track of yellow line to okay, that will be the screw. And okay, the next, number 11, will be the gear latch. Let me zoom it closer. Make sure that it's pointing, it reads gear latch instead of, okay, this is gear latch. So I put it here. Component number 11. Then the 12 will be the internal gear. So I zoom into the internal gear. This is the internal gear. So make sure that maintain in line. We have a yellow line here. It means in line the balloons. This will be 12. And we have 13 for the handle. I will go for here for the 13. And 14 is the middle plate. So I will go zoom in like this. So this will be the middle plate. Okay, let me do some adjustment. Okay, I think I've listed all the component until 14. And in terms of neatness of the drawing, let me do the labeling. Alright, I think it's quite okay as a balloons. Okay. Okay, let me save again my drawing. So, okay, under the material here, this material, as I mentioned to you just now, the most, if you do much proper way, actually the material will be automatically listed, but I will explain to you using the basic way. So I will add the material manually by adding the text. Okay, if I double click here, not edit the text, if I double click at the table here, so I will do material, I type manually. The container is plastic. Let me copy this word. So I will go for double click at this one. So I paste it, and the blade is not plastic steel. The rubbering is rubber. The lid is plastic. Okay, let me pause this video. Then later I will show you the end result. Okay, as you can see, this is the end result. I already put all the proper material to the component. Like for example, container vertical shaft is plastic, and the lid is plastic. This plate is plastic. The pulley, the gear latch, internal gear, and also the handle is plastic, and also the middle plate. Okay, certain component like this blade, actually this blade is non-standard blade, so it should be there. I put the material steel, but the screw, and also if you look, the flat coil spring is a standard component. It means that this part we will not manufacture this part, so this part we just order it, since they are standard components. So we should not put material here under at this BOM. For example, like screw and screw M1.5, the flat coil spring, and the screw M3.5, since they are all standard components. So they will not, we should not put the material and also the drawing number here. Alright, I think this is the basic list I put here. Okay, under the drawing number here, the drawing number here, actually I just put it manually like this. For example, the container is the base one, so I put it as a 1. Vertical shaft is drawing number 2. And if you look the blade, if the blade is not a standard component, it should be drawing number 3. So it means every part or component that have drawing number, it means you have to do detailed drawing on for this part. Screw is a standard component, so I will not put drawing number. The rubbering is kind like, if this rubbering is not a standard rubbering, so it will have the drawing. So this will be drawing number 4. And the lid, yes, would be drawing number 5. And base plate will be drawing number 6. Flat coil spring, as I mentioned to you, flat coil spring is a standard component. We don't have drawing number. And the screw as well, the pulley, yes, we have drawing number 7. And the screw is a standard component, no drawing number. The gear lash is, yes, we have gear lash. Internal gear, we have drawing number 9. Handle, drawing number 10. And middle plate, drawing number 11. Okay, we have 1, 2, 3, 4, 5, 6, 7, 6, 7, 8, 9, 10. So parts that have drawing number, it means we will manufacture this component. So part like standard, we don't manufacture, we simply order it since they are standard components. So in terms of drawing number here, so this is assembly drawing, so it will follow by exploded drawing. Then after the exploded drawing, then it will follow by detailed drawing of each component. So component that have drawing number, it means this component will be manufactured. Okay, let me do some adjustment here. Let me move around. Snap again at this borderline and reduce this width of this column, and also this material need to be reduced, so we will have optimum space. And quantity like this, and drawing number also I reduce the column. And also in terms of the, if you look here, I will make it left and center again to make sure that this kind like in line. But it's okay, I think it's okay to me, and I can edit manually, but for purpose of this video I need to make the time short, so I can edit it later. Okay, let me drag again this title block to this. Make sure that it snaps to the border. Alright, now I have my BOM. Okay, actually BOM I can save it if I click at this corner of the BOM. If I right click at it, I can save as I name it as my BOM. Let me replace the old one. So it means that this BOM can be used for another setting of your either exploded drawing and assembly drawing or exploded drawing. So it means you don't have to do the setting of this BOM again and again. You can just restore the BOM that you have saved. Okay, the last thing to mention here, after you have done the assembly drawing, you can save save as typical Solidworks draw file. You can also export your assembly drawing into PDF by file, you save as, and go for PDF, and you can type save the name like assembly drawing, but the format is PDF. Then I save it. Okay, after I've saved the file, then I will browse the file. if you, as you can see, this is a PDS format of our assembly drawing. Okay, I hope by looking at this video, I hope this video will help you on your project of you doing your assembly drawing. Inshallah, in the next video, I will do how I will do exploded drawing for my mini planner. But before that, do not forget to click like and subscribe my channel. Assalamualaikum warahmatullahi wabarakatuh.